Good morning to all of you. Am I audible?
Yes, sir.
Yeah. So welcome to this course ECE 4031 Artificial Intelligence with Python. So in this course, we are typically going to focus on the foundations of artificial intelligence, how this domain got formed, and then gradually we will march towards machine learning concepts, and finally we'll see the applications of machine learning and some sort of deep learning. So traditionally the programming styles were different than the AI based styles. Okay, so what is the traditional or conventional programming way? Say you want to find the average of three numbers. So what you do, you write a code in C language or in Python. What you do, you ask three numbers to the user, say X, Y, Z, and you store the values entered by user in variables X, Y, Z, and then you find the average X plus Y plus Z, whole thing divided by 3, and then you display the average. This is how you do the computation. Here, the algorithm is num1 plus num2 plus num3 whole thing divided by 3. So we know the algorithm, we operate the algorithm on input, and we get the output. So output is not known before the process. So what is known? Inputs are known, three numbers, and algorithm is known. So this is conventional style of programming. But scientists, they said, okay, this is how the computers work, fine. But humans, they typically don't work for their intelligent tasks in this way. I'll give you some examples. Say there are some kids in home. Those kids, they observe the adults in the home, that how they behave, how they do a particular task. Okay, and they try to mimic that. Okay, this is how I have to do. So they observe and they learn. Okay, they observe and they learn. So this is how human brain operates mostly. Okay, observation and copying it or learning it. So scientists, they said, okay, so if we want to replicate the tasks that are done by human brain, then we have to follow this methodology where the input is known, output is known, and internal process is unknown. So internal process is to be figured out. Okay. I'll give few examples so that this concept will become more clear. Here I am writing values of X and values of Y. Okay. Okay, so this is input to the system. Okay, X is input, Y is output. Just observe this table, and from this table tell me that for 7 X is equal to 7, what will be the value of Y? What will be the value of Y? So if we observe, we can get that Y is equal to 49. isn't it? We can see the that the system is doing the square of the input. So here the algorithm was not known to us, but our brain can figure it out that if this is the input, this is the output, then what must be the algorithm or what must be the mapping. So this is the different way or a non-conventional way of coding where the input and output pair is given and internal algorithm is to be figured out. So AI based system do the same. Another uh, application of AI based system I'll tell. Say there is a face recognition system. Okay. Say there is a face system. Okay. So this face recognition system, what it does, when some input is given, so this is input X and output Y. So this is say matrix 1. For matrix 1, it says John. Okay. And for matrix 2, it says Ted. Okay, like that. So matrix is a set of numbers. For this matrix, the output is John. So this set of numbers, it is say image. So that image contains a face, and that face is of John. Another matrix contains image, and that is from for Ted. Okay, so this information is fed to this system. It learned. Later on, if I give matrix 3, then from this mapping, if it is close to John's matrix, then the output will be John. Okay. So in face recognition system also, we give the input and output. We don't give the algorithm. So the algorithm will figure it out that how to fit this X to Y. Okay, so this is in theory lectures, this concept will become more clear. Just we are discussing an overview part over here. Okay, so this is our syllabus, AI with Python. So course objective is it covers in-depth knowledge of various AI techniques using Python. Okay. So here Python programming is important. In one of the lab, we started to brush up the concept of Python. So gradually from Python, we will cover NumPy, SciPy, Matplotlib, Pandas, and then we will go towards machine learning. So what are the expected course outcomes? So after completing this course, you will have a good understanding of fundamentals of AI concepts. You will have the knowledge of understanding the concepts of Python. So that is mostly covered in module 1, and then implement the AI concept in real world applications along with Python. So you will use Python to apply to many real world problems. So you might be aware that there is huge demand in industry for computer vision engineers and machine learning engineers who code in Python as well as R, but mostly in Python. So that's why this course is really important, because it is accompanied with lab. So this is more hands-on kind of course. Okay, but on a theoretical front, you can see how this field evolved, like basics of AI, then why we need to learn AI. Okay, so necessity is typically we want to replicate human brain, how human brain performs certain processes, so that we need to replicate. So for that purpose, we need in this AI-based programming. And then what are different applications? Like one application I told you, face recognition. There are many applications of AI, like fingerprint recognition, iris recognition. So they are biometrics. Then medical image classification, and then sports data classification. So many. There are so many applications. Then branches of AI, intelligence. So nowadays, if you search AI in and you just type the field, you will get some data like AI in oil industry, you'll get some data. AI in sports industry, AI in Olympics, you'll get some data. Okay, so it means that in every field, people are applying AI to get more insights. Okay, and if we observe the AI-based system as a say robot, okay, so robot it acts as an agent, okay, and that robot it works in certain space, so that space is called as environment. The robot may not be visualized as exactly the physical robot which moves, okay, and which performs some tasks. Like chatbot, you might have use your bank accounts where the chatbot is there who says that how may I help you, isn't it? So that chat-based robots are also designed. There, the physical robot is not present, but AI-based robot is there, which addresses the queries raised by the customer. Okay, so this agent may be physical or agent may be in software form. Okay, and next is Python for AI. So here the concepts of Python starting from the operation on numbers, then strings, and then the looping constructs, and then lists, dictionaries, tuples. So all these things we are going to discuss. Then which IDEs we have to use, these things also we are going to discuss in module 1. In module 2, we will focus on supervised learning. So supervised means to the algorithm, we provide the data as well as its label. Okay. So for example, over here, M1 is a data and John is a label. So we are telling that if this is the matrix, if this is the data, its label is John. If this is the matrix, its label is Ted. Okay. So likewise, we provide the labels also. This kind of learning is known as supervised learning. Okay. Uh, then in supervised learning, there are so many algorithms like naive-Bayes algorithm, then support vector machine algorithm. So in support vector machine, we can perform classification as well as regression. Okay, so classification means if the output is discrete in nature, it is classification. If it is continuous in nature, it is regression. So as of now, if you're not comfortable with this term, don't worry. At the time of theory lecture, this concept will be absolutely clear to you. So what is regression? What is classification? And before providing the data to these algorithms, we need to do some pre-processing. So that's my pre-processing of data, like mean removal and denoising, that kind of operations we perform. And we also perform label encoding. Okay, so because scikit-learn package don't need the labels in text format, like the text label, like John. So we may allot some number to John. Say John is 01, Ted is 02. So likewise, we allot some numbers. So that is called as label encoding. So that we perform in module 2. In module 3, we will again discuss this sub part of supervised learning. Really. So in supervised learning, ensemble learning is there. Say there is some movie. Before pandemic days, the movies were used to release in theaters, and say 10 of your friends watch certain movie. They watched it, and now you want to watch that movie. So what you may do, you may ask all of them that how was the movie. If 7 of them say that okay, the movie was good, then you take the decision. Okay, so 7 people are saying the movie is good. Okay, I should go and watch it. All right. Nowadays, we may rely on online ratings. Okay, so rating is also kind of thing that we use to take the decision. So here in Ensemble Learning, same thing happens. We give the task to multiple classifiers. Okay, and we ask that what is the output. Okay, so say cat and dog classification problem is there. there is some image, and we ask whether it is cat or it is dog to 10 different classifiers, and 7 of them say that it is a cat. Okay, so final outcome will be cat. So like that, these algorithms operate. So this is called as Ensemble Learning. Here, the random forests. So decision tree is the basic part of this Ensemble Learning, and multiple decision trees. Hello, hello. Am I audible? Hello, am I audible?
Yes, sir.
Yes, sir.
Yeah, yeah. So multiple decision trees, they form the random forest, and one extended algorithm is extremely random forests. So these algorithms we are going to discuss in module 3. That is also supervised learning. And then sometimes the data is imbalanced. Okay, say there is some rare disease, and you acquire the data about the rare disease. So very few cases are there. Mostly the cases are negative, and very few cases are positive. Say in 1,000 samples, you get only 3 samples of that disease as a positive. Okay, other samples are negative. So when you collect the data, 1,000 samples are there, but the samples are highly skewed towards negative. Okay, only 3 samples are positive. Such a data is called as imbalanced data. So for imbalanced data, we have to do some balancing. Otherwise, classifier is biased. It will always say negative. Okay. So we have to introduce synthetic samples where the negative data is provided in more quantity. So there are some techniques to provide the synthetic samples, like SMOTE is one of the technique to address this imbalance. So we are going to perform the experiments during lab sessions. These things will be more clear, because if you want to work as a data scientist at that time, these concepts are really helpful to you. Okay, because the data which is given to the data scientist, it is highly raw in nature, and we have to pre-process the data, we have to address all these issues, and then we have to apply the classifier algorithms. Okay, so that's why these data balancing techniques are important. And next is sometimes some classifiers, they have parameters. Okay, and they are called as hyperparameters. Hyperparameter means their values cannot be determined using some mathematical formula. Okay, there is no mathematical formula for finding those parameters. Then how to address those parameters? So we have to go manually, like I will set 10 and check what is the output. I will set it 20, then what is the output? Now I'm monitoring 10, I'm monitoring 20. What about the values in between 11 to 19? I ignored. Why? Because how many times I will run the experiment? So at that time, there are some techniques called grid search. In grid search, you simply say 10, 11, 12, 13, up to 20, and it will check for each value, and it will perform the experiment on itself, and it will give you the best value. Okay, so that's why grid search is powerful. There are many algorithms like this. So this process which I just mentioned, this is called as hyperparameter tuning. Hyperparameter tuning. Okay, then next is feature importance. Like say some data is there, and that data contains many columns. Some columns are really important for classification, but others are useless. Like say some column is there called a date, and for a certain experiment, date is not required. So the date column may confuse the classifier. So at the time we have to remove, or we have to ignore some columns. So this is called as feature selection. Feature selection. And then we'll see the application of this extremely random forest regressor or traffic prediction. So there are many experiments we will perform while learning these modules, like in module 2, we will classify the income data, then we will estimate the housing prices, then we will predict the traffic. And one important thing is we will develop the end-to-end pipeline. In one of the lab, I will cover this, which is highly in demand in industry, that you develop some app, a web app, okay, and at the background, the machine learning model will run. But in the foreground, the GUI should be there in the form of web page, like it should be web page. And whenever user enters some data and wants to take some decision, then the machine learning model, which is sitting at the back end, it will process the data and it will give the decision based on the experience it has gained from earlier examples. Okay, so this web app we are going to develop, which is definitely not there in this list of experiments. Okay, but this is something which is add-on because this is in demand. Okay. Then this was supervised learning, module 2, module 3. In module 4, we are going to discuss unsupervised learning. So unsupervised learning means what? Say some kid is there, again kid. So you mix 3 different kinds of objects. Say you mix tomatoes, you mix apples, and you mix bananas. So tomatoes, apples, and bananas. You mix it up and give it to the kid, and you say that separate these. Now kid doesn't know whether it is called as tomato or apple or banana. Names the kid doesn't know, but the kid can separate these. Okay, so how? So based on the shape of object, based on the color of the object, based on the texture of the object, these 3 different fruits can be separated. Okay, so here, if this M1, M2 is provided and label is not provided, this is called as unsupervised learning. Okay, only data is provided and the algorithm has to make the decision, has to separate or segregate. So this is called as clustering. This is also called as clustering. So in unsupervised learning, typically the algorithms focus on clustering the data with k-means algorithm, and mean shift algorithm is also used for clustering. And after we perform the clustering, how good the clustering is, whether the objects are correctly clustered, so that quality can be estimated using silhouette scores. So these things we are going to discuss. And then Gaussian mixture model, this is very powerful probability based concept which is used to do the unsupervised learning. So in speech recognition, people they use Gaussian mixture model. Okay. Also, we'll have the experiments to segment the market based on shopping patterns. So there's another algorithm called as affinity propagation. So there's again unsupervised learning. Okay. So this one module is devoted for unsupervised learning, because mostly the ML models, they come with these 2, supervised learning. Okay, and very small part of industry they use unsupervised learning. So only one module. And next is recommender systems. Say you open YouTube app, and in YouTube you get some recommendations. So how these recommendations are shown? So there are say millions of videos on YouTube on various topics. So how we get these recommendations? And these recommendations are really useful, isn't it? If we just scroll down, we select the video and we watch that video. Okay. So why? Because they are displayed in such a way that user will like those recommendations. User will watch those videos. If they are irrelevant, you will not scroll down, isn't it? Say you are a student and say you're a BTech student and say the YouTube is showing you the kids songs, say nursery rhymes. So will you scroll down? No. Okay. So if you're a BTech student, say in electronics, and if the recommendations are say NPTEL videos of electronic devices or Python programming, such a recommendations are there which are shown to you, then you may be interested. You may watch those videos. Okay. So likewise, various factors are considered while showing the recommendations. So what are the algorithms behind them? So that is the uh, the syllabus we are going to cover in module 5. So there are various techniques like collaborative filtering, then k nearest neighbor based classifier to show the nearest neighbor based recommendations. Then finally we will build a movie recommendation system. Okay, so this is hands-on building a movie recommendation system. The next part is logic programming. So there are some languages like Prolog. Okay, so here we'll use Prolog language, and this language is typically based on logic, that is true or false. Okay, only two possible values are there, true or false. So how to code using Prolog and how to implement, say, puzzle solver or geography analysis or family tree based parsing. Like if some family tree is given as input, and we may ask certain question that who is aunt of who, like that. So like family tree based interpretation. So that is possible in Prolog. So we are going to use Prolog for module 6. Still in robotics, this Prolog is used in various European countries. Okay. Then next is module 7. This is very important. Applications of AI. So here heuristic search techniques means multiple values are taken and we check which is the best possible outcome. Okay, so there are certain scenarios where this is needed. Next is genetic algorithms. So by taking inspiration from nature or biological processes, we try to solve some mathematical problem. So that is genetic algorithms. Then building games with AI. So we will build a game with AI. Okay, so it is a say one player game. So we will be at one end, other end will be AI based agent. Okay, and we will play with that AI based agent. And then we will build a speech recognizer. It's some small setup speech signals will be taken, and we'll try to recognize those signals in say real time. So speech recognition. And then last one is object detection and tracking. So we will track our face, how the face moves in front of camera. We are going to track. And next thing is we are going to detect eyes. We are going to detect face. So these two experiments we are going to perform with the help of OpenCV. Now this OpenCV is also in huge demand in industry because this open source computer vision library, and it was developed by Intel, and in many applications they use it as a base software. On top of that, they build the things. Okay, so that's why this module 7 is really important. Module 8 will be covered by industry person on the latest trends in industry related to AI. Okay, so this is theory part. Textbook is AI with Python by Pratik Joshi. So this book is really important. First, AI with Python by Pratik Joshi is really important. Please have a copy of this book with you. And this book is applicable to module 2, 3, 4, 5, 6, 7. Textbook number 1. For module 1, this Peter Norvig and Stuart Russell, AI, a modern approach. So this book number 3 will be referred by us for module 1. For module 1, for this basics of AI necessity, application branches, AI agent environment, up to this part, agent and environment, we will be using book number 3, textbook number 3. Okay, so Russell and Norvig. So I have a copy of this textbook number 3, textbook number 1. And rest of the books, they are important. So as and when required, I will tell you which book is to be referred. But as of now, I have copies of this book number 1 and 3 with you. Then evaluation. So there will be CAT and DA and 2 quizzes and PAT. So I already have sent you an email that contains the schedule and deadlines. So there will be 2 quizzes, quiz 1, quiz 2, and 1 DA for theory part. And for lab, there will be 5 tasks. Each task will carry 12 marks. And at the end, we are going to conduct the lab part that contains 40 marks as a weightage. Then lab exercises. So these are a few things, but we are going to, because this is indicative, so we are going to have our own way of performing the lab experiments. So you can refer it, but you have to attend every lab to become proficient in this particular course. So this was we discussed syllabus and broad overview of AI in this first lecture. Now it is time for question and answer. So you can ask the question and answer. You can type into the chat or you can speak into the mic. What is the limitation? The number of addresses, I would say. Any doubts, any queries?
No, sir.
Okay. So this first lecture, I will not start with syllabus in lecture 1. In next lecture, we're going to begin with module 1, that is basics of AI. Okay. So with this, we'll stop here. I'll download the attendance list and then you can log out. And all the operations will be carried out exercise. Take example, take a discipline. What is the available number? Yeah, I have downloaded the attendance list. Thank you for attending this lecture. Bye bye.
Thank you, sir.